Well, welcome back. Here we are in 13-1. So that is the last chapter of Algebra 2. For some of you, that means it is just about over. 6 sections to go, and chapter 13 will be done. For this whole chapter, we're going to be talking about trigonometry. And I know most of you, or all of you, really worked on trigonometry and geometry class and come in with a great background. Now, if your background is a little bit shaky, that's okay. We're gonna still go through it all step by step, and I'm sure you'll get back on the horse real soon. Well, we have our 6 basic functions: sine, cosine, tangent, all functions that you've learned before, and then cosecant, secant, cotangent. Kind of some new functions, but they're just very similar and related to the sine, cosine, tangent, so it shouldn't take you long to pick up on that. Let's take a look right away at the definitions for right triangle trigonometry. And in the beginning of this chapter, that's what we're going to be talking about. It's right triangle trig. So I hope some of you guys remember sa, or I like to say so, ke, toa. All right. SOHCAHTOA is an acronym that helps you to remember the sine, the cosine, and the tangent. And you will see soon that it helps you with the cosecant, the secant, and the cotangent. Sine would be opposite over hypotenuse. All right. Cosine would be adjacent over hypotenuse. Adjacent over hypotenuse. And tangent would be opposite over adjacent. Now, cosecant is the actual reciprocal of sine, and so it's hypotenuse over opposite. So cosecant, you got to try to remember that cosecant goes with sine; those things go together. And cosine goes with secant; those go together. So we're going to have hypotenuse over adjacent. And then on the tangent, cotangent, it's easy to remember that goes with tangent. That's adjacent over opposite. So when you're asked to find those things, it's very similar. You do all the same stuff. So, like I said earlier, cosecant is actually 1 over the sine of theta. Secant is 1 over the cosine of theta. And cotangent is 1 over the tangent of theta. So if you didn't remember those things very well, I went out on the internet and I found this for you. You could just wear this shirt to class that day. You just order one of those online and you'd be all set. So that it's help you pick up a lot of ladies, I'm sure, gentlemen. That's your way to get a prom date, wearing that shirt right there. So let's see what we have. Evaluate the 6 trigonometric functions of this triangle that you have right here. So let's see what we can find. The first thing you need to do is find the hypotenuse. So we use Pythagorean theorem to find the hypotenuse. So we did 8 squared plus 15 squared. Well, 8 squared is 64, and 15 squared is 225. So when I add 64 plus 225, I get 289. And the square root of 289 is 17. So my hypotenuse over there is 17. This right here, 17. So my triangle is 8, 15, 17. If I'm trying to find sine of theta, and what I'd like to do is I like to take that theta, and I imagine that that's me standing in the corner, and there's this triangle, this right triangle, and I'm standing in the corner, and the side down here that I can touch it, I'm adjacent to it. The hypotenuse, that's the long side, and then opposite is the side all the way over there to the other side. So that's kind of how I think about it. I'm standing in that corner. That helps me to remember. So sine was opposite over hypotenuse, and the side opposite of my sigma there is 8, and the hypotenuse was 17. So the sine was 8 over 17. Now cosecant's just that flipped upside down, so that's 17 over 8. Cosine is adjacent over hypotenuse. All right. Adjacent over hypotenuse. Well, what's adjacent to it? What's next to it? right here, 15, right? So 15 over 17, and then that would mean the secant would be 17 over 15. The secant goes with cosine, and the tangent is opposite over adjacent, which in this case happens to be 8 over 15, and the cotangent would be 15 over 8. All right. There are special trigonometric values, and these really made a lot more sense to me once I had taught geometry a few times, because when you teach geometry, you teach those special right triangles. And so if you guys remember your special right triangles, the 1, 1, or I think in geometry class when we taught that, we taught it like this: A, and A square roots of 2. And when we had this one, the 30, 60, 90, that's a terrible 30, 60, 90, but it was A, 2A, and A square roots of 3. A square roots of 3. And so if I thought about this in that way, if I thought about what's happening, and when we do that, if I say find 30 degrees, the sine of 30, well, this one up here was the 30, okay? And remember, sine is opposite over hypotenuse, so it was 1/2. Opposite over hypotenuse, like on this t-shirt over here. And if I thought about it as a cosine of 30, that was adjacent over hypotenuse, which is square root of 3 over 2. And if I thought about it as tangent, now the tangent's the one that got a little sketchy. It ended up being 1 over the square root of 3. And we remember what cannot be on the bottom of a fraction, square root of 3. So I multiply the top and the bottom by the square root of 3, and I get the square root of 3 over 3. And that's what the tangent of 30 equals. Now, unfortunately, you're going to have to memorize all these. There's ways to do it, but going back to your special right triangles will help you the most. The sine of 45, so I can take either one of these and do the opposite over the hypotenuse. Well, when I do 1 over the square root of 2, 1 over the square root of 2, and I multiply the top and the bottom by the square root of 2, I get the square root of 2 over 2. And that's what the sine of 45, actually that's what the cosine of 45 also equals, the square root of 2 over 2. So those are easy to memorize. And the tangent of it equals 1. The one little trick that I will tell you often is that tangent equals, the tangent of theta equals, see how it's opposite over adjacent? Well, sine is opposite, cosine is adjacent. Tangent actually equals sine over cosine. So, if we took the square root of 2 over 2, divided it by the square root of 2 over 2, we get 1. Alright? Now, the sine of 60, if I look at that down here, it's opposite over hypotenuse, which is the square root of 3 over 2. It looks exactly like the cosine of 30. That is not a coincidence. That is what happens. Let's see if I can make that look like a 3. I don't know. That's a 3 if you're listening at home there. Now, remember what we talked about with the cosecants and the secants and the cotangents. They're just flipped upside down of all these things. So if I took the tangent of 30, the 1 over the square root of 3, now it's just the square root of 3 over 1. So it ends up being the square root of, just square root of 3 over 1. If I took this one right here that I'm looking for, the 45, the secant of 45, that goes with the cosecant. So that ends up being not 1 over the square root of 2, remember we found it up here, it ends up being the square root of 2 over 1. So just the square root of 2. And if I take a look at the cosecant of 60, well, that's the square root of 3 over 2. Well, now it's 2 over the square root of 3. Can't have the square root of 3 on the bottom, so I multiply the top and the bottom by the square root of 3, and I get 2 square roots of 3 over 3. And that goes right here. 2 square roots of 3 over 3. Alright, so on when we're doing these ones here, you're going to use a calculator. It says use your calculator. Now, it's very important that you have a calculator with a tangent button, a sine button, and a cosine button. You're going to notice that your calculator does not have a secant button. It does not have a cosecant button. It does not have a cotangent button. You'll have to just do the reciprocal of those things when you get there. So let's take a look. A and B are complementary angles. So if I gave you angle B, let me make this a little bit bigger, easier to write. If I gave you 56, I hope that you know that angle A down here is going to be 90 minus 56. 90 minus 56, which is going to be 34. Alright? Now the tangent of 56 is the opposite over the adjacent. The opposite being this B over here, which I don't know. Opposite over adjacent. That B, which I do not know, is what I'm trying to find, but I know it's over 13. So what I'm going to do is I'm going to grab my calculator. I'm going to make sure my calculator is in degree mode. And for those of you who don't know, there's a mode button on the upper, right next to your second button. And mine was in radians, so yours might be too. And you're going to do the tan of 56, which is going to be 1.48. And then you're going to multiply it by 13, because you're going to multiply both sides by 13, so you can get rid of that. So these cross out. So when I times that by 13, times this by 13, I end up with about 19.3 for an answer. Okay, and then when I'm solving all these pieces, I say, oh, B right there, that's 19.3, and I found the angle A was 34, because what they're going to say to you is solve the triangle. When they say solve the triangle, that means all 6 parts. 3 angles, 3 sides, you got to find them all. The only thing left to find here is C. Now, your book said, oh, let's use secant to find C. I bet you some of you guys are sitting at home right now going, why the heck would I ever use secant when it's going to be a lot of work to do secant? I have Pythagorean theorem. I have that tool in my toolbox. Why don't I just use that? It's a very, very good question. Probably they just want you to get some practice using secant. Remember, secant is 1 over cosine. So the secant of 56 is going to be 1 over the cosine of 56. Alright? And remember, cosine was adjacent over hypotenuse, so secant is hypotenuse over adjacent. We just found that we don't know the hypotenuse, but we just found that we know that what is adjacent to 56 is 13. So I can put that right there. So I'm going to do 1 divided by the cosine of 56 on my calculator, and then I'm going to multiply it by 13. And I'm going to get multiply by 13, and I'm going to get 23.24. Now, I will never know how you do that. If you use Pythagorean theorem, great. That's probably what I would have done, is use Pythagorean theorem. I probably would not have used secant. But that's just what they wanted us to do. Alright, you go ahead and take a moment and solve all of the things that you need here. So on the first one, they want you to find the 6 trigonometric functions. They want you to find sine of theta equals cosine of theta equals tangent of theta equals cosecant of theta equals secant and cotangent. And I'll give you a little hint. I'll do the first one and then you pause it. The sine of theta is going to be opposite over hypotenuse. 12 over 4 square roots of 13. 12 over 4 square roots of 13. But Mr. Remy, I can't have a square root of 13 on the bottom. You're right. You also see that 4 goes into 12, so that becomes 3 over the square root of 13. Okay. Now, if the sine is 3 over the square root of 13, then the cosecant is the square root of 13 over 3, and I can leave that right there. I can stop. For the sine, though, I have to multiply the top and the bottom by the square root of 13 and get 3 square roots of 13 over 13. Alright, you guys take a moment and do the rest of it. Okay, so welcome back. Hopefully you paused for just a moment. The next step, I hope right away you're starting to notice you don't have this number down here. And I hope what you did is just do the Pythagorean theorem. If you came up with 18.76 on that, then that'll give you the decimal that you want. I know they're giving us an exact number in this 4 square roots of 13. I'm not going to get too crazy about that. If you get that far, I'm pretty happy. In fact, you know, decimals are not the end of the world if that's what you need to do. Obviously, there's good answers and there's great answers. You determine where you want to be there. On the cosine of theta there was the adjacent over the hypotenuse, and so it would be that 18.76 divided by 4 square roots of 13, and maybe you just did a decimal, maybe you went all the way with it, but it was already kind of in decimal form. So when you did that number, you got 1.3. Now remember, if I did 18.76 divided by 4 square roots of 13, on the secant I got 4 square roots of 13. 4 square roots of 13 divided by 18.76. And 0.77, something like that. Now the tangent was the opposite over adjacent, so that's going to be 12 over 18.76. And the cotangent, it was going to be just the opposite of that, 18.76 divided by 12. And whatever those decimals are, when you put them in your calculator, is fine. Now, in number 2 here, they ask you to solve the rest of this. And so they wanted you to find b, they want you to find little a, and they want you to find little b. And that's going to be a very common problem you'll do in this chapter, in this section. So if the first one to find is b. If this is a 180-degree triangle, which they all are, and we have 90 degrees over here, the other two are going to add up to 90 degrees. So 90 minus 37, 53 degrees. So now I know that that's 53 degrees. That can help me in finding some things. What I might want to do first is do the sine of 37a equals the opposite, a, over the hypotenuse. So if I do the sine of 37, and I get 0.6018, and then I times it by 22, I get 13.24. So little a equals 13.24. And then I probably would just do the Pythagorean theorem at this point. So I would do 13.24 squared, and that would be 175. So then I would do 22 squared minus the 175.3, and then I would square root that number. And when I square root that number, I got 1756. So little b equals 1756. And that will work out just great. Alright, last page. Alright, so let's break this up a little bit. I got these guys here. He said they're trapped on an island. It says, you never heard of Sakatoa? Here, I'll show you. On a triangle, you can do straight sides and the hypotenuse, and then it's like, and he's going on and on and on and on. And then over here it says, I guess this means we're going to die on this island. So I thought that was kind of funny. Maybe I'm just a dork math teacher though too. So building height. You are measuring the height of your school building. You stand 25 feet from the base of the building. So right here, you're 25 feet away. The angle of elevation, I guess this was 25 right here. And the angle of elevation is 62 degrees. That was 62 right there. Estimate the height of the school building. Well, what you're trying to find is the opposite. You have the adjacent. So I'm going to do the tan of 62 equals the opposite over the adjacent, which is simply going to be the tan of 62 times 25. And if I do that, I get that my school building is approximately 47 feet tall. That seems like an awful big school building, like 5 stories tall or something. Alright. Go ahead and take a look at this one here. You give it a pause and see what you get. Alright. A kite makes an angle of 59 degrees with the ground. So in these first couple, 59 degrees, they're all going to, the string of the kite is 40 feet. These first couple, they're all going to be right triangles that we're talking about. How far above the ground, so I want X over here, is this kite going to be? So we got a kite up here. Definition of a kite. Anybody from geometry class? Definition of a kite. 2 pairs of consecutive congruent sides. Yeah. Alright, so what are we going to use? We have opposite and hypotenuse. Hopefully somebody said sine. So the sine of 59 equals x over 40. So I'm going to do the sine of 59 times 40. And I'm going to get 34.29. And that's good. You guys are all set. Thanks, guys. We will see you tomorrow.